You're not going to miss this episode of the AI Show. We talk all about GPT-5, what you need to know. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking about all about GPT-5, what you need to know with my friend Jennifer Marsman. Jennifer, it's been so long. How you doing?
I know, Seth. It's great to see you. How are things?
Oh, I can't complain. But here's the thing. For people who don't know you, why don't you introduce yourself and then I'll get to who's their thing before we get to that.
Very nice. So my name is Jennifer Marsman. I'm a principal engineer in the office of the CTO at Microsoft. So one of the things that I enjoy doing is kind of really testing the new models as they come out. So one of the things I've done recently is kind of an exploration of GPT-5. So I put some code out on a public repo, which I'll share with you at the end, but I just wanted to walk you through some of the scenarios of things that I think are particularly cool about GPT-5.
All right, so now here's the thing part. GPT-5 came out. What makes it different? And that's the first thing. And then once we talk about the differences, then we can get into like looking at what the differences are.
Yeah, for sure. So, first of all, like some of these other models, GPT-5 is a family of models. So it's not just a single model, but an entire family of models. So there's like a mini, a nano, and a full version within there. Another thing that is interesting about GPT-5 is that before GPT-5, we kind of had the GPT class of models, and then we had like the O1, O3, like O star class of models, right? And what made the O star models different was that they were reasoning models. So they were using under the covers where we couldn't necessarily always see it, but they were using a chain of thought reasoning to be able to solve more complex questions than you could get with the GPT model at the time. Now, what's cool about GPT-5 is that it's kind of marrying these two together. And so a lot of times from some of the public endpoints where you may call GPT-5, there's actually some model routing that can happen, which can direct you to either a reasoning or a non-reasoning version of GPT-5 on the back end. So that's one of the things that's super cool. And then, of course, there's been improvements in the capabilities as well. So we'll talk about all of that.
So let me see if I understand it. So the O3 reasoning models would do like a chain of thought, and the O star ones. GPT-5 sort of builds upon that by being able to route to other models that maybe it thinks it needs to do reasoning, maybe it thinks it needs to do something easy. Is that the gist of it?
So let's clarify. So it depends on how you're calling the model, right? So if I'm calling the API, then I am calling a specific model. So I could call, for example, the GPT-5 kind of reasoning models, which would be the GPT-5, the GPT-5 mini, and the GPT-5 nano. But then there's also a GPT-5 chat version, which is kind of the non-reasoning one that's also available. And so if you go to like an endpoint like Copilot or things like that, then when you call what's the GPT-5 experience, it may be doing some auto switching behind the scenes. Given the query that you give it, there is some logic that decides, like a really small classifier that says, hey, is this a good thing for reasoning or a non-reasoning model? And then it routes it to the right GPT-5 on the back end. Now, when you're calling the API, you can actually get the exact same behavior because there's something new called the model router. And so when you call the model, actually, it's not new, right? We introduced it at Build a couple of years ago, but or not a couple of years ago, a little bit ago.
Yeah.
But now what we've added to it, like what came out in the last release of Model Router, is that it routes between the GPT-5 models as well now. So you can get GPT-5 reasoning and non-reasoning in there as well. So that's a great endpoint where you may want to like save a little money. Like maybe you have some, chat where it's just going to be, hey, how you doing? Kind of questions where the tokens that you use on a reasoning model would make it super expensive, but you have more complex things as well. So dynamically based on the prompt, if you call like the model router, for example, it will make a decision on should I route this to reasoning or non-reasoning.
I see. And so when you're having the full chat experience online, there's some goodness happening in the back end.
Mm-hmm.
You can use that as well through the API, but otherwise you can just call the model straight or through model router.
Exactly.
Okay.
Yep, you got it.
Yeah. This was confusing to me, and so I'm so glad you're here. Is there something you can show us to give us like a flavor of what's going on?
All right, so all of this code is live. I just kicked it off, so it may or may not actually be done running yet. So what I'm actually going to do is jump over to this where I have it filled, and then I'll walk you through some of these, and then we'll jump back because it was taking a second
Let's
there.
do it.
So what I have right here is some very simple just setting up environment variables and pulling this in here. You can go through and look through this. I'll share my repo at the end where I have all of these. But this is just pulling in. I'm using the default, I'm using Entra ID, which is more secure. So I'm doing, I have this set to true, and then I'm AZ login after that so that I do that. But you can also make this false and use API key instead. And then I just have some helper methods. So I'm kind of looking if you're using API key versus Entra. And then GPT-5 actually works with the responses API as well as the chat completions API. So I set up clients for each of those just to kind of show that they all work so people can use whatever version they want. And then I have simple things that call each of those, the responses API, the chat completions API. And then I have one that calls the model router as well, just to kind of show that at the end too. All right, so then we saw chat completion up there, we saw model router, and then here's responses API, and then I have a version that works with images as well. So all of those just helper methods. I'm going to skip a few of these. I just throw these in there to show that you can use both the responses API and chat completions, but this isn't very interesting, so I'm going to skip some
By the
of
way,
this stuff.
just a little coda here. Responses versus completions. What's the big difference? I
Yeah.
try to look at it and I didn't see a huge
Yeah. So
difference.
this has been out for a while. The responses API isn't new, but I think it was announced when we first did the reasoning models, but it's a little bit closer to like what you would get with the assistance API. So a little bit more of that stuff is kind of managed for you. So it's like a step away from completions, but responses is kind of the future way of looking. So I tend to use responses API. More often than chat completions with GPT-5, just because I know that's going to be the thing going forward.
Okay, cool. Good to know. Sorry for the coda.
Yeah. Oh, no problem at all. Okay, so I'm going to skip. This is kind of interesting, but like there's some different things right here. There's a new, if you don't want very verbose output, there's this low version, but that's not as interesting. Let's jump to this because this one's a little more interesting. So I wanted to talk about like sometimes when you are having this conversation, you want something to be very well reasoned, but you want a more succinct answer. You don't want to be verbose. So what I did here is I have another little pretty printing helper method. And I know both of us both had children leaving home recently. Seth
I
and I were
know.
talking before we started recording. And so when I was in that frame of mind when I was writing this demo, so I wrote an emotional poem about a daughter leaving home for college is my prompt.
Great. Now you're going
And
to
then
start the waterworks for both of us. What's
I
the
know. We
matter
can't
with
read them.
us?
I'm just going to show you really fast, but we're not going to stop and read them because we will both start crying.
Okay.
But so I have a little set here of low, medium, and high, and then I cycle through each one of them and show what it looks like. And the pretty printing gives you this nice little purple and how many tokens. So you see one with kind of the low, so we have a less verbose response. Here's low, and that was 434 tokens. And I'm not going to read it, but
Yeah,
oh my
I
God.
can't read that
I
stuff.
know, we can't read
What
it
are you
right now.
doing to me?
Yeah, I know. And then medium right here. So you see that got up to like around 800 tokens. And then we had a high version, which was almost 1,300 tokens. And so I'm not going to read these, but you guys can read those. Pause at your leisure and go through and make mistakes.
Yeah, I can't read those.
Okay, yep, we're going to skip that.
Yeah,
but
okay.
you saw how you could, and there's a lot of times, Seth, where I've been like struggling because like let's say you want to use reasoning, so you want reasoning turned on because you want to ask a complex query. So reasoning effort is like one parameter you can mess with, but then you may want a succinct answer. So now you can kind of mess with the reasoning level, that reasoning effort that we see here. Reasoning effort is separate than how verbose the end result is for output tokens.
Now, is this
you can
specific
manage
to
the number of
GPT-5?
reasoning tokens and the number of output tokens separately.
I see. Now, is this specific? Sorry to interrupt. Is this specific to GPT-5 or is it just?
It is. So these are new. So
I see.
what's new in GPT-5 is that they added one level, like the I believe or this is new. This verbosity. I'm not actually sure if it's verbosity or verbosity when we say it like that, but that's new. And then the reasoning effort, I think, was there before. But we added minimal. The minimal is new. Like before, it was just low, medium, high. and minimal was new with GPT-5.
This is cool.
Yeah. So, okay, I'm going to skip a couple of these too. You can use custom tools. You can do stuff. All of this is in my public repo. So go through and like do all of these in your leisure. But I know you and I have a set amount of time here. So the next thing I wanted to do is do playing games with a web front end. So one of the things, like if Satya came to me right now and said, Jennifer, I need a GPT-5 demo, like what's the coolest thing that it can do? Honestly, one of the things I've been most impressed with is if you say, hey, I want a single page of HTML, like just give me a complete program that does like something fairly sophisticated, like all in one go. So this is a single prompt that I'm sending it, and I'm saying I want a playable game of checkers and a single page of HTML. I'm going to make them not the normal colors, right? So make them blue and pink. Pink always goes first. Human controls this. So I just made up some basic rules here. And then I'm saying, give me instructions on how to move the pieces in the UI, just because I don't know what it's going to do exactly. And I want a clean, simple UI. And this output this, I set my number to 1. So this will be checkers 1. So if I go here to where my output directory is, let's go to checkers 1. Did I make a copy of it? Oh, dear. Let's open this guy up. All right.
Wow.
So it generated this. So it's a
That's
nice
insane.
kind of UI. It gave me some things. So let's just go ahead and try to play this, I guess. I'm going to go here first, maybe. Let's do that.
Wait, it even does all the like.
It's highlighting. Yeah, it's like what are the valid
Jeez.
moves are highlighting. Or at least when I touch this, this is a valid move. When I touch this, this highlights as a valid move. Woo! Isn't that cool?
And
So now I can try to do this, but this guy can get me. Let's do it anyway. I want to kind of give up the. Yeah. Okay.
so it even built the algorithm to do the.
It did all of this.
That's
Yes.
not an
So
easy algorithm. Like I'm thinking of how to
no.
build this in my head, right? And it's like, wow, that would take some
Yeah.
time.
It's a lot of stuff. It's a lot of stuff. So I'm going to just keep going for as long as I can here. Yes. Great. That's fine. Oh, double jump. Darn it. I didn't see that one. Okay. So I'm trying to just get to the king.
Uh-huh.
If I can get it to king me, but like this guy's going to get me here. Let me see if I can back this guy up to support me. Oh, I have to jump you. Nice. Okay. Here. And
And
here.
it just wrote this all in one shot.
It wrote this all in a single prompt. Okay, now I can make it. Let's see if when I get to the king, I just want to show that. I see how it turned to a little K, and
Oh
now the
my good.
rules change, and I can go this way. So like really, really cool stuff. So like
Oh.
again, a single prompt, we just made a complete like working game. And I've done this with a number of different things as well. So that was just one example. If you jump back to my code, I think I did Sudoku didn't work quite as well, but there was some Sudoku as I was playing with. I was like trying to generate online quizzes. So I said, write a quiz of like 10 multiple choice questions where it sorts you into one of the Hogwarts houses, like see how that works. And like these things are all like really, really good. So it's amazing just kind of the level that you get from like a single prompt. So the like complete end-to-end game is one of the things that I'm most impressed with.
That's cool.
It's really cool.
Yeah.
Yeah. So I'm gonna skip through some of these things here. Here's another one. So this is another problem that I used a lot with reasoning models. This was a real life problem, Seth. My dog, like I had to take him to the emergency room once,
Oh no.
late at night. And they sent me away with 3 medicines, and they said one medication needs to be taken twice a day. Another medication needs to be taken 3 times a day, but it can't be taken within 2 hours of the first medication. And then there's another medication that can be taken at the same time as this one, blah, 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 blah. And I came home and literally I was like, what? Like help me please, because like that was just a lot, especially when it was like a middle of the night thing with the dog. And so like I literally came home and I threw the problem at like GPT-5, or this was actually happened a while ago. I threw it at GPT-4, but it was like, give me like, it's a constraint satisfaction problem, right? So I'm like, here's the thing, like just do this and see how it works. And so it actually does a great job. It takes the 2 that are supposed to be done twice a day. It spaces them 12 hours apart, which is optimal. And then it spaces these all very nicely. a 10, a 4, and 11 p.m. for the other one. And they're all within the 2-hour boundaries and very good. So like this was so helpful to me for that.
That
And
is
then,
very helpful. I mean,
isn't
just
that
like
cool?
you know,
Yeah.
let me put our phrases out here. Let me put my
Yeah.
phrases because there's like problems sometimes where we just have like a brain because we're
It,
tired or hungry.
you
Putting it into
know,
this is going to be so helpful.
that's the way to do it. Like there are sometimes that even if it wasn't completely right, like I could just at least have something to start with to
Yes.
like check the answer and then be like, okay, this is good. So like that's another one that I was a big fan of. Now the other cool thing about GPT-5 is that it does support out of the box the same modalities as we got with GPT-4o. So we have image understanding by default in the first version. So I wanted to try this on a couple of image things. So let me show you like what I'm actually doing here. If we open up another window. So I am passing in this image. So it's a screenshot of a Wordle game that I was playing. And you see that there's not, that many options yet left. I think it could be like, oh, it can't even be rains because the S can't be there.
Yeah.
So I think it might even have to be right. So it wasn't the hardest. I purposely chose an easier Wordle puzzle just to see if it could get it like in one thing. But remember that it has to do all of that image extraction. It has to have the OCR of understanding all the letters. It has to know the colors and what each color means. And it has to know the positions, which has typically been hard. And the only thing I did was pass in that one screenshot. And then my prompt was, what is a good next word to guess in this Wordle puzzle? And it came up with resin,
Ooh,
which is fabulous, like
I would have
in
never
one
got that.
go. That is really good because
Yeah.
resin, if we just go back and look, RESIN is perfect. Like it uses all of the letters in the place that doesn't work. So like that, I was like super impressed with that because I have a Wordle talk that I did a while ago, and like this used to be way harder, let me tell you.
Yeah.
Go look on the internet, find my Wordle talk, and you'll see like me trying to do it with earlier versions of these image understanding models, and it was not this easy. Here's another one. This was another thing. So another thing that you and I know has been hard historically for image understanding models is counting, like counting things in an image.
Yes.
That's always been a tricky problem. So what I did here was I found a thing of the royal family. This is an image of the royal family, and if you count, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 people in this image. Okay. So what I said here is, okay, if we do have, my prompt was just 70 gifts are to be distributed equally among the people in the photo, and the remainder should be given to charity. How many gifts will each person get? How much is given to charity? And again, I know I just wanted a random picture with a lot of people in it and happened to choose the royal family. I don't think this scenario necessarily makes a lot of sense, but you can think about like, okay, if there's a birthday party and you buy a thing of candy and there's
Yeah.
70 pieces of candy and you must have the same number in every goodie bag, Seth, or you're going
Yeah.
to get in
Yeah. I know.
trouble. Your
Yeah.
kids are going to give it
Otherwise,
to you. Yeah,
kids will be like,
you
hey,
can't
they
mess
got
up there.
3 and I got 2.
Exactly.
Yeah.
You will get in trouble. So they all have to be excellent. And then the remainder given to charity goes into my mouth. But there you go. So that's maybe a scenario that's a little more sense. But it correctly figured out there are 8 people in the photo. So it did the correct counting. And then it was even able to do the math, the corresponding math here. So each person gets 8 gifts because that's the full total thing. And then 70 minus 8 times 8, 64 is 6 gifts left. So really, really like, yay. Like I was so impressed that it kind of was able to do all of that like in one go in a single pass of the model, right?
And
So
historically,
really, really
like
neat.
I've never trusted these models to do math because it's a language model, but it
Yeah.
somehow is able through language
Getting
to do
better and
math.
better. It's getting better and better. It's really impressive.
This is
And
cool.
then Sakib, right? So, dear friend, who is blind, and so when I look at these image understanding models, one of the things I always think about is, like, how well could this do to kind of help us? So, what I have here is an image of like a big kitchen, um, and I said, okay, I'm blind, and this is the view in front of me. I want a snack of an apple with peanut butter and a glass of milk. We keep the peanut butter in the pantry. Give detailed instructions on how to do this. So like if I couldn't see and I was in a new place, like maybe that was the office or something in a little snack area, like what would you do? And so it's describing the scene to me here. This is not is great. It doesn't always do something like this. I don't like that it's like, if this is different, let us know. But I guess things can change. So it's like step forward to the island until you hit a stool. So that's pretty good right there. Now there are apples over here, and then the pantry is back here is where I was assuming the peanut butter was. So let's look and see how well it did. Get a cutting board and a plate from the island, walk around its backside with the wall towards the cook till you touch the back counter. Feel for a wooden cutting board that's, oh, I didn't even see the wooden cutting board. Straight up. Oh, this one right here. I guess the backslash. Nice. Okay, yeah. Okay, so it did it.
Oh no, it did the wrong thing.
Yeah, did it? No, it got it. Get an apple. So did it find the apple? Turn towards the left wall, right? Okay, that's correct. There's a 2-tier fruit stand. It was 2-tier. Yay! So you can see that, you can get the idea. I don't want to spend too much time, but this is like really, really cool. Like I love when we can use AI for good and find compelling scenarios like this that can actually make a difference and help people. And I even love this ending. Like, want me to stay with you step by step? Say next when you complete a step, and I'll guide you through the following one.
Oh, that's nice.
Isn't that cool? Okay, and then the last thing I wanted to show real briefly, because I know we're probably at time already, but I just have to show you model selector too, is the having the actual model selector. So this is what we get with GPT, again, with GPT-5, when we call that, we're always going to get GPT-5 directly. And that's what I was doing above for most of the prompts, which had reasoning capabilities. But if I call model selector, so you just do the model router, the value of that, it's another model that you can just select in Foundry. And so now if I call that as the model instead of GPT-5 directly, it will choose between various models. And so I did a simple prompt of hello, which will choose between like the various GPT-5 models. And notice that it chose the smallest one, which was really smart because you don't need a super like amazing model to answer a greeting, right? So it gave me this response back, and it used the nano, which was great. Now for the checkers prompt, I was actually hoping it would use a slightly more advanced one, but here it did choose to use nano again in this thing. We could actually test this one and see if it works or not. I want to jump back to the one that I started running here at the beginning. Let's see how this one did. Okay, so this one actually did what I wanted. So I used a slightly different prompt right here. I have a couple other complicated prompts here. So here's another like a puzzle where I have a 4x4 grid, and then we have like constraints here where these things can't be together, these things can't be together, and then explain step by step usually helps prompt it to use a better reasoning model here.
Makes sense.
And then and then here I also have find the largest palindrome that's a product of two things. And I chose that one for the demo because it's easiest to explain and check. Then this one takes a little bit more time to check. This one, so hello, we use nano, which was great. And then here we actually noticed that it used mini, right? So yay. And these won't be, 100% right. It won't always route to the same thing 100%, but it's getting better and better. So really, really cool here that it used mini to solve a harder problem. And then I did the same thing here with the images as well, where I had a simple describe this image, and it used the nano one. And in this case, it chose the wrong thing. It chose nano, and river. I don't think would river work. Let's go back to the RI. No, it would not, because we know that E is not there, and we know that I is not there. So actually, I think it needed a slightly better model for the river one, but we probably did not train on Wordle puzzles.
Yeah, but that's okay. Like when we, I think people are like, oh, I got it wrong. No, well, these are tools. And as developers, we need to harness the tools to be like, if it gets things wrong, we need to figure out a way to change them. Yeah.
Exactly, my friend. So, and honestly, they're getting better and better too. And so that can be a really cool way to see, or you can test it, or you can call it directly. Like if it was actually a Wordle game where I was only using it to solve Wordle, then I would just directly call the model that I know works very well for that.
Well,
so
this is awesome.
So cool. So let me just share with you the repo. So if you would like to try all of these, so you'll know that this was not cherry picked, that I literally like ran these or was running them and jumping to one that I had run before. This was all just real code. You can get it yourself at github.com/Jennifer Marsman/GPT-5 research.
And I put it right below so people can get it. And if you want to learn about OpenAI and Azure AI Foundry models, that is in there as well. Jennifer, it's always a pleasure. Thank you. There was a lot of questions I had about GPT-5, and you've cleared up a lot of them, and you showed me some of the capabilities. It's been really cool. Thanks for being with us, my friend.
Yes, always good to see you. Take care.
Take care. And thank you so much for watching. We're learning all about GPT-5, what you need to know with my friend Jennifer Marsman. Thank you so much for watching, and hopefully we'll see you next time. Take care.